In today's math lesson, we will be covering Lesson 12, Session 1. This is in your November 1st folder on Schoology. Remember to open assignments with Cami. Also remember that when you are done with assignments that you should go to the corner up here and click the Turn In button in order to submit your work. So we are talking about ratios. And our goal is to understand what ratios are and to be able to use ratio language. We have two start problems today. A 2 feet wide walkway surrounds a rectangular swimming pool. The swimming pool is 12 feet wide and 16 feet long. Uh, Remember when you're doing these start problems to make sure that you pause the video, try the start problems, and then come back to it. Excuse me. So, number 13, we want to figure out the area of the walkway. So we can do that by finding the area of the larger rectangle first. So we would want to know what is our distance from here to here, and then our distance from here to here. We know that our walkway on each side is 2 feet. So if we know from here to here is 12, and we add 2 feet on each side, 2 feet on each side is 4. So 12 plus 4 is 14. Then we have the other side. We know that from here to here inside on the swimming pool is 16 feet, 2 feet on each side, so 16 plus 4 would give us 20. So the first step is to multiply 20 times 14. That will give us 280. Then we want to multiply for our inside area here of the swimming pool. And we have a 12 by 16 swimming pool, so we want to multiply 12 times 16. When we multiply this, we do 6 times 2 is 12. 2, regroup the 1. 6 times 1 is 1, plus 1 is 7, so 72. Then we are moving over to our tens place in our second factor, so we place 0 there, and then we have 1 times 2 is 2, and 1 times 1 is 1. We add this together, and we get 192. Now we subtract 280 minus 192. We have to borrow for this. So this becomes a 7, this is a 10, this becomes a 1, this is 17. So now we have 10 minus 2, which would be 8. And then we have 17 minus 9, which would be 6. Oh, wait, something didn't work out right. 12. Oh, sorry. This should have been 16. 16 times 20. 12 plus 4 more is 16. So 16 times 20. 0, 2 times 6 is 12, 2, carry your 1. 2 times 1 is 2, plus the 1 is 3. So 320 minus 192. Let's try that one. So again, we're borrowing. We have 10, we have 11, and we have 2. So we have 8. 11 minus 9 is 2. And then 2 minus 1 is 1. So 128. So our answer is C for number 13 on star problems. Let's take a look at number 14. We have a fish tank in the shape of a right rectangular prism. And then it gives us our measurements here. What is the maximum amount of water the fish tank can hold? So when we want to know the amount that a three-dimensional object can contain, we're talking about volume. So volume equals length times width times height. And when we do this, we have a length of, excuse me. So we have a length of 36 and 1/4 times a width of 12 3/4 times 18 1/4. So the first step would be to change all of these into improper fractions. So you would do 4 times 36 plus 1, and that would be your improper fraction for here, and then continue across. Then you would multiply across the top, multiply across the bottom, and when you finish out the problem, you should get D. Now, this section of the test would have been calculator active, and that's where these questions came from. They came from your TE21 test that you took on Mastery Connect. So 8,434 and 59/64. So this is something you could have used a calculator for. All right. Those are our start problems. When we're talking about ratios, a ratio is a division comparison. Ratios can also be written in simplest terms or reduced, or you could put in simplest form or made smaller. However you want to word that, but we can reduce or simplify ratios because since ratios are division comparisons, they are fractions. For example, in this, we have 2 dogs for every 3 cats. So that can be written as a fraction. It can be written with a colon in between. It can be written with words, 2 dogs to 3 cats. So ratios compare 2 quantities. They compare 2 amounts. So that's what we will be doing with ratios. So number 1 for the model, it says you can use multiplication as a way to compare 2 quantities. In Charles's lab group, there are 4 times as many test tubes as students. Complete the model to show this comparison. A circle represents a student and a rectangle represents a test tube. So there's 1, 2, 3, 4 students, 1 test tube. You have to complete the model. We have 1, 2 test tubes. We need 4, so we add 2 for 1 student. So 4 to 2. Again, 4 to 1. Sorry, not 4 to 2. We had to add 2. But 4 to 1 is our ratio. B says 1 more student is added to Charles's group. So if we add 1 more circle, what else needs to be added as far as our test tubes? Well, we have 1 to 4 in each of our groups, right? So it would be 4 test tubes. You could write 4 rectangles if you wanted to, since those are what represent our test tubes. But that's what we need to do that one. All right. Number 2 says you can also use a ratio to compare 2 quantities. One way to describe a ratio relationship is to use the language for every or for each. In Eldora's lab group, there are 3 test tubes for every 1 student. Complete the model to show this ratio relationship. So 3 test tubes for every student. So we need 3 to 1. 3 to 1. 3 to 1. So that is a model. Use your model to complete the sentences that use ratio language. For every 1 student, there are 3 test tubes. There are 3 test tubes for each student. There is 1 student for every 3 test tubes. So all of those are different ways that we can use that language of for every or for each. We have for every here, for each here, and for every here. So different ways to write the same thing. All right, we are going to skip over the discuss it and move on to the model it. The Spanish Club is having a party. They plan to serve 6 tacos for every 3 guests. So we have 1 taco represented in our model, but we need 6. because we have 6 tacos for each guest. And it's for every 3 guests, so we need 3 circles to represent our guest. Use ratio language to write 2 different sentences that compare number of tacos to guest. So I could say for every 3 guests, oops, there are 6 tacos. I could also say um, every 3 guests get 6 tacos. If I wanted to use the each, I would have to bring my ratio down to 1. So if I group these by 1, I could have 3 to 1. Oh, sorry, not 3 to 1, 2 to 1, 2 to 1, and 2 to 1. So I could say for every guest, there are 3 tacos. So those are all different ways to write the same thing, right? Now, C says to use your model to help explain. So let me go back to the model. So we had 6 tacos for every 3 guests, right? And it says Julong says there will be 2 tacos for every 1 guest. Use your model to help you explain. Well, in my model, I can see that I can group these into groups so that there are 2 squares for every 1 circle. Or for every circle, you don't have to put the 1 there. So that is how I would use my model to explain that Julong is correct. There would be 2 tacos for every 1 guest. Again, we're going to skip discuss it, and that's just because we don't really have anybody to discuss back and forth with if you're at home working by yourself. So use the faces below to practice writing ratios. So we have different faces here. And what we're going to count up first is teeth to no teeth. And the thing that we noticed in class is these that look like they have maybe 1 tooth, that is a tongue. All right, so we're looking actual teeth. So teeth, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 teeth to how many no teeth? Well, I have a group of 8, a group of 8, a group of 8. 3 groups of 8 is 24, right? And I just said 9 have teeth. So 24 minus 9 is going to give me 15. So 15 do not have teeth. So 9 to 15. And you can write the ratio in any way you want to. The easiest way that students have found in class is to use the colon to write their ratios. So after looking at teeth to no teeth, you look for eyebrows to total faces. So we know that the total faces is 24, right? We just talked about that. But eyebrows, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 to 24. And you would keep going in this manner. So tongues to total faces. So let's see, 1, 2, 3, 4 have tongues out of 24 total. And you would just keep going with this, finding the ratios for each of these: angry faces to eyebrows, big eyes to teeth, etc. So you can do that part on your own. And if you have any questions, please reach out and ask. But our next section here in this A question, it says write ratios below. So teeth to no teeth, we said that was 9 to 15. Now, if the comparison was no teeth to teeth, no teeth was 15, teeth is 9. They want you to determine if those ratios are different. And the best way to think of this, or the way that comes to mind for me, is if ratios are division comparisons and they can be written as fractions, then this would be 9/15ths and this one would be 15/9ths. 15ths and ninths are not the same thing. They have different units. This one is using 15ths and this one's using ninths as the units. So no, they're not the same thing. So that would be, for me, how I would justify the fact that they are not the same. Most students will say that yes, they are, you just flip them around. Well, it's not like that with ratios because we are comparing two amounts. So because they are a comparison, because you can write them as fractions, they are not the same thing by just flipping them around, as students would say. So it does matter what order you put them in. So that brings us to the order in which a ratio is written is blank to the meaning. I had my students just put important to the meaning. You could choose a different word to put there, but it does matter the order that you put them in. All right. So then we have question number 1 here. In the lunchroom, there are 100 milk cartons at lunch. When lunch was over, 80 cartons of milk had been purchased. So I want you to try to answer A and B on your own. So pause the video and do that, and then come back and check out the answers. So for A, it wants to know the ratio of milk cartons purchased to total. So purchased to total, right? Well, we know that 80 cartons had been purchased, and we know that there were 100 cartons total. Now, you can choose how you write that. Like I said earlier, most of the students in the classroom choose to use a colon. It's probably one of the shortest ways to write it. So 80 to 100. Question B says, what is the ratio of the number of milk cartons remaining to the number of milk cartons purchased? So remaining to purchased. Well, we know that 80 were purchased, so we have to figure out how many were remaining. Well, we know that our total was 100. 100 minus the amount that was purchased of 80 leaves us with 20. So this ratio is 20 to 80. All right, number 4 is the exit ticket for today. It says explain how the ratios 5 tacos for every 2 guests and 2 tacos for every 5 guests are different. Include a model in your explanation. So I will go over the models with you, but then I want you to explain on your own. So if we have 5 tacos to guest, right? 5 to 2, taco, right? And we have 2 guests. They want to know how that is different than 2 tacos. So tacos being 2 for every 5 guests. Taco, guest. Sorry, wrong room. guest. All right. So how are these two things different? How is 5 tacos to every 2 guests different than 2 tacos for every 5 guests? So you are going to explain how those two models are different. That is it for today's math lesson. I will see you guys next time.